Yeah, I have started.
Okay, great. So good afternoon, everyone, and welcome to this webinar hosted by the Oceanic Chapter of System Dynamics Society. My name is Miriam, and I'm really pleased to be joining you from beautiful and very cold Wurundjeri country. Thank you all for coming along to this session. Before we start, I want to acknowledge the traditional owners and custodians of the land we're all calling in from today, who were systems thinkers way long before system dynamics or really any kind of science came along, and just express my respect for the elders past and present. And in spirit with this last week's NIDOC week, strength, vision, and legacy was the theme. And I really hope that we can reconnect to the new strands to the old roots at some point and build something much better moving forward. Or even better, not much better. It was pretty good to start with, I think. And today we're delighted to have Cameron Allen as our guest speaker. I personally have the pleasure to rub virtual shoulders with him at the Monash Sustainable Development Institute, and where he's a senior research fellow and recently received a DECRA fellowship. He is an interdisciplinary sustainability scientist, and his research explores the drivers and dynamics of sustainability transformations to accelerate change towards net zero and the SDGs, or SDGs for Sustainable Development Goals. And he's really been pioneering work on applying system dynamics to the SDGs, and generally brings naturally a systemic lens to global complex challenges. He's advised governments, UN bodies, and development partners across the globe on development planning, SDG integration, and policy coherence, and other things, I'm pretty sure. So his insights are particularly helpful as well to our chapter, because we're really exploring how system dynamics can inform real-world policy and planning across our region. So in today's session, Cameron will share some lessons learned from applying system dynamics and related methods across a selection of projects. So we're very excited having him. And please join me in welcome Cameron Allen. Over to you.
Thanks very much, Miriam. I might actually stand. And yeah, it's a real pleasure to be here. Thanks for the invitation to join the Oceania chapter, which I do join from time to time and see the great research that's been done on system dynamics in this region. I'd like to also acknowledge the traditional owners of the lands where I am here in Brisbane, the Turrbal and Yagara peoples, and pay my respects to their elders past and present. So today I'm going to talk a bit about research that I've been doing over the last several years, which has used system dynamics for different purposes. And I guess just the general context of our research is on sustainable development and policy making. And we've done projects in Australia and more broadly in the Southeast Asia region as well. And I did originally plan to talk about 3 projects that we've done, but when I put together my slides, I realized that was far too ambitious. So I'll focus in on 2 projects. The first is one on the transboundary air pollution challenge in countries in Southeast Asia, which was very much a participatory system dynamics modelling study for the UN as the client. And the second one is very different to that. It's our Transforming Australia assessment, which is more a flagship initiative of the Monash Sustainable Development Institute, where I work, which I guess focuses more on advocacy and outreach around the Sustainable Development Goals, or the SDGs, as we call them. So the first study on air pollution in Thailand and Lao PDR, it's a project that I actually worked on a few years ago, but we only just published a paper on it in Sustainability Science this year. We actually delivered the project during COVID, which had its own challenges. And I'd just like to acknowledge my co-authors here from the Millennium Institute, as well as the UN. So the context for the project was that it was a pilot study commissioned by the UN Development Programme Regional Hub, which is based in Bangkok. And it was actually led by the Millennium Institute, which is, if you don't know of them, a specialist institute in system dynamics modelling and policy analysis. So they've been doing a lot of projects to support policy on sustainability issues for several decades now. And in this project, we focused in at the subnational level in two provinces, one in Thailand and one in Vientiane, one in Chiang Rai province in Thailand and Vientiane province in Lao PDR. And in both these provinces and indeed throughout the Southeast Asia region, air pollution is a real challenge. It's a priority challenge. And it really has a, depending on the province, has a different mix of activities and drivers that are the source, I guess, of that air pollution. Of key concern is fine particulates, or particulate matter PM2.5, which are quite damaging to health. So they have significant health impacts, particularly chronic health problems that occur, over a number of years. And important sources of PM2.5 emissions include energy transport, industrial activities, cooking, heating in households, as well as burning of waste, forest fires, and agricultural waste. There's a range of different stakeholders and perspectives and priorities and interests, so it's really a complex transboundary challenge that affects the whole of the region, and a lot of blame's often allocated to different groups, often marginal groups, for being the main contributors or sources of air pollution. There's a pretty complex policy and regulatory landscape in place in these countries to try and address air pollution, which has had some limited success. But what they've found is that, the growing population and economic growth in the region are sort of offsetting the benefits from these policies, and they're looking for additional sort of cost-effective actions that can help to address these challenges. So it's very much a participatory style system dynamics modelling study, undertaken first in Chiang Rai province and then in Vientiane. And we followed, roughly 5 steps. The first was really the model conceptualization, which included stakeholder systems mapping workshops. We then did the model development work, model review and validation. We then ran some scenario exploration and gaming workshops, and then delivered the final deliverables to the clients. But essentially, we're aiming to develop a tool that can help support decision-making around air pollution and identify cost-effective interventions. The workshops and activities involved a range of stakeholders. So we included national and provincial governments, NGOs, international organisations, research institutes, etc. And we built a simulation model, a system dynamic simulation model for each province, which included a user interface that could then be used in our scenario gaming or scenario explanation workshops. So a bit more on the different stages of the project. The model conceptualization work involved essentially systems mapping of important air pollutants, the direct and indirect sources and drivers of those air pollutants, the direct and indirect impacts associated with those air pollutants, and then potential interventions that could abate or reduce emissions, or actually target more on the health and impact side of things. And essentially, we broke the workshop participants into different groups. Each group developed one of these Miro board systems maps, and then presented that back to the plenary. So they all sort of had their own approach and own sort of key pollutants and drivers, etc. they focused on. And after the workshop, we then consolidated that into a single Miro board, which went back to the stakeholders to review. And then we used that to develop some key CLDs, or causal loop diagrams, of some of the key variables and drivers and dynamics associated with air pollution in the province. So that conceptual work then fed into the model development. And the model that we developed, we called the integrated air pollution model, which is a provincial scale model that simulates annual emissions of pollutants, of 3 different air pollutants, including particulate matter, PM2.5, It's really built around 18 different source activities. So that yellow box in the middle, and this is sort of a snapshot, I guess, of the model in Stellar Architect. The yellow box there is where we simulated activity volumes, so the sort of the fuel consumed by a range of different activities, based on a combination of different economic and social drivers. So we include economic drivers in red there and social drivers in blue. And the different source activities included, activities related to transport, industry, waste, agriculture, forest fires, etc. These emissions were then converted into the activity volumes were then converted into emissions of pollutants, and then emissions were converted into concentrations using dispersion modelling. So the model also included 12 different policy interventions, which can either reduce the activity rates or abate emissions from different sources, or they can also reduce the impacts of emissions, say through the use of masks or things like that. And we calibrated the model based on data for different drivers, for source activities, for air pollution concentrations, etc. And that generally used the optimization procedures that are available in Stellar software. And I guess in addition to that, we built this user interface which sits over the top of the model, and is actually hosted on the IC Exchange. So you can even go online and play around with that. This is just a few snapshots from the user interface. So it includes some information about each of the modules. If you want to learn more about the model structure for each of those modules, you can either click on the Learn More tab and flick through those, or jump straight to the simulation page. So once we'd calibrated the model, we were able to then do some baseline projections. This just shows the projections for PM 2.5 emissions in each of the provinces in Chiang Rai and Vientiane. So we can see that key sources of emissions in Chiang Rai include transport, household cooking and heating, waste burning, while in Vientiane important sources include transport again, cooking and heating again, waste, as well as industrial activities. So it's a more urban setting, I guess, in Vientiane with some additional industrial sources of emissions. And on the right there, just the projections for PM 2.5 concentrations. So the two lines at the top, the solid lines are for urban emissions, and the dotted lines are for rural emissions in each of those provinces. So the projections show that, based on the assumptions that we've made, that emissions and concentrations are projected to steadily increase over time. So the next stage of the project was the scenario gaming and exploration workshops. This is a snapshot of the main simulation page in the user interface, which enables users to sort of, non-technical users to go in and play around with different policy settings. And if you look at the green tabs down the bottom there, that is each of the different policy interventions, which you can click on and then enter in a certain amount of investment in each of those policies. Above that are the projections for emissions from different sectors, including transport, energy, forests, forest fires, agriculture, industry, waste, households, etc. So that includes the total emissions per year, as well as the share of emissions. And above that is then the projections for concentration of PM 2.5 emissions, which then links to health impacts and feedbacks to the economic and social drivers again. There's also a range of other pages in the user interface where you can go through and look at, particular assumptions around unit costs or assumptions around population growth, economic growth, and all of these things can actually be adjusted in the model. So you can play around with those assumptions as well and see how they impact model results. And then there's additional pages that have, charts and things for different, emissions from different sectors and stuff like that. So you can dig into the results a bit more. So in the scenario workshops, we had a number of activities. firstly was some initial testing. So we sort of familiarised, participants with the user interface and how to run different scenarios. And how to then look through the results and interpret some of the model behaviour. So we asked participants to again break out into different groups, and each group then went through and implemented some trial interventions of around $100,000 per annum for each of the different sectors, to then see how these interventions impacted emissions from different sectors and concentration levels overall. So you can see on the right there where you've got that sort of big green tab, and with the charts, this is essentially where you could enter in an amount of investment each year over a 10-year period. Then you could click through as well to some more information about those particular policies where it had the unit costs and things like that, and you can actually play around with those unit costs as well. And it just runs simultaneously, so as soon as you enter in a policy, it updates those projections. So in the second activity, we then allocated each group a virtual fund of $150 million over a 10-year period, and asked them to try to deliver the best outcome in terms of emissions reduction in their province. So I guess the aim was to really try to get them to select an optimal set of policies that reduced PM2.5 concentrations as much as possible. And participants were able to, develop their own policy scenarios and discuss the results, discuss their assumptions around which sources they thought were most important and which ones, are more important in terms of the projections and data that we have. And each group then presents back to plenary, and we discussed and challenged, I guess, some of these preconceived ideas. And slowly build some consensus around these, which are the most important sources, the most cost-effective policies, etc. The final activity then looked at cross-border effects. So the model also simulated emissions coming in from provinces surrounding each of these provinces. So each province had, 3 or 4 surrounding provinces that were either domestic or international. And they were able to play around with some assumptions in terms of policy action in these other provinces. So if these provinces implemented similar policies to address air pollution, what would the implications be for these cross-border emissions, etc.? So overall, each of the groups would allocate a certain percentage of the budget for different policy measures. You can see these update in the model. So on the left, you can see sort of the total budget that you've spent, then the implications in terms of emissions and concentrations. And what we found is that groups had varying levels of success in reducing emissions. But in both provinces, we could see pretty good reductions in air pollution emissions as a result of these different policies. And the charts here, we see, the baseline scenario in blue, and in green, the investment scenario, as we called it. So this is after they've implemented their different policy measures. But in both provinces, we saw that the largest reductions came from policies relating to waste burning, to household cooking and heating. And we're also able to look at, the costs of different policies and cost effectiveness of different policies. So in this table, we include results for Chiang Rai in the top 4 rows and Vientiane in the bottom 4 rows. So looking at Chiang Rai, that top row shows the total reduction in emissions of PM2.5 associated with different sectors. The next row shows the cost of emissions reduction per kilogram. The next row shows the percentage of emissions in different sectors before we implement the policies, and then the final row, the percentage of emissions from different sectors after the policies. So we really saw that across the 2 provinces that the most cost-effective policies were around waste burning, household cooking, while the more expensive and less effective emission policies were really around transport and industry emissions. And then after these policies were implemented, we also saw, the largest share of emissions really remained in the transport and industry sectors. So there's a fair amount of inertia in these sectors where policies are less effective, and continued growth in emissions from these sectors anticipated over time, so it offsets gains made in reducing emissions. So I guess overall, in terms of policy implications, we found that an effective medium-term strategy could focus on investments in these large polluting sectors that also have these cost-effective upstream policy measures, particularly in waste and in heating, cooking. In both provinces, there was also this considerable inertia in transport emissions. So continued growth in the vehicle fleet is really projected to offset improvements, and investments in sort of electrification of transport take a lot of time to replace that vehicle fleet. So there's a fair bit of inertia in those emissions. In Vientiane, it was a similar case for industry, which is growing rapidly, but it's very expensive to implement abatement measures in this sector. So participants sort of discussed the need for more upstream measures in these sectors to help reduce emissions, including mode shifting in transport, for example. And it also served to highlight that air pollution is not just a domestic challenge; it's really a transboundary challenge. In terms of lessons learned from project implementation, so we did find that building consensus around these findings, the model projections was challenged because of people's preconceived ideas on air pollution. In particular, there was a strong stakeholder perception that agricultural burning and that forest fires and often transboundary sources were the largest contributors to air pollution, and it's often they often associated this with marginalised groups, say Indigenous communities in forested areas lighting forest fires. But when we looked at the model projections, we saw that these are actually marginal contributors to overall annual emissions across the whole year. So they might contribute in particular events, but over a year, the largest share is really coming from day-to-day activities like transport, cooking, as well as waste burning. So it really helped, I think, the stakeholders to get a broader view and see air pollution as a sort of a socio-economic development challenge, rather than pointing blame at particular groups. It's something that everyone really had responsibility for. And the user interface was kind of cool because it let people play around with the model and get a feel for it and run their own policy simulations and look at the results. So moving on, I'll shift now, pivot to the Transform Australia project. So this is a very different project. It's not a participatory system dynamics modelling type study. It's really an independent expert assessment of Australia's progress on the Sustainable Development Goals. So the 17 SDGs that were adopted in 2015 by all countries, including Australia. And it's a flagship project where we have assessed Australia's progress several times now, including the latest assessment at the end of last year, which we launched this year. And the latest assessment is a bit different because we didn't just look at our progress in the past on the SDGs or current status on SDGs. We also use system dynamics modelling to explore policies that could accelerate Australia's progress on the SDGs. So the assessment, well, the SDGs report includes these two components, the progress assessment and the modelling, sort of looking ahead into the future. And I'll really just be talking about that modelling today. But I should mention that all the results from this study are available online on if you Google Transforming Australia, you can access the progress results, you can access the modelling results and learn more about our key findings. But the model that we use for the project is the ISDG Australia model, which we've been, adapting and further developing over a number of years now. The model was developed originally by the Millennium Institute, and it's sort of the latest model in an iteration of different models that they've developed over several decades and applied in different national contexts. They've had probably close to 50 national applications now of the model, and sort of learned and built on experience in each case. But essentially, I would say it's an integrated assessment model built in system dynamics language. So it's a very large model. It's over 3,000 variables. It's extremely integrated and modular. So there's 36 different modules, which are all interconnected across 3 dimensions: economy, society, environment. And we've been adapting the model and further developing it since around 2017, and applied it a number of times in Australia. And the model's validated on over 30 years of historic data. We've published a range of papers in some nice journals. So the model comprises these 11 environmental modules, including land, water, energy, materials, emissions, etc. 10 social and demographic modules, so it simulates population, fertility and mortality, as well as education, health, employment, income distribution, poverty, etc. And then 10 economic modules, including economic production in agriculture, industry services, aggregate GDP, investment, etc., etc. There's also 5 additional models which simulate progress on different SDGs targets, which are also used to input different policies. So it includes a suite of different policy measures, which I'll get to a bit in a moment. And across those 3,000 plus variables, there's 80 different SDGs indicators. So we can actually simulate through different scenarios the amount of progress made towards 80 different SDGs targets across all 17 goals. So we've published a range of papers, including a couple of big studies in nature communications and nature sustainability, which really focus more on the SDGs, as well as a bunch of studies we've been doing in different topics, including on built environment, greenhouse gas emissions, or net zero transport, as well as a study we did in Fiji where we adapted the model for Fiji. But most of the results for Transforming Australia are really based on this study at the top in Nature Communications, where we modelled 6 transformations, 6 sustainable development transformations for Australia. And I'd just like to acknowledge my co-authors again here, who I've been working with for a number of years on this research. So a closer look at the model. The version that I've been using is built in Vensim. It essentially has a stock and flow structure. So each of the different modules, which you can access through, the drop-down menu, have, a stock variable, flows, and then a range of different auxiliary variables, including variables that are used for calibration, so data variables, as well as variables that are used in optimization. So these calibration parameters. And the model is also disaggregated, so it includes a range of different arrays or subscripts. So population, for example, is disaggregated by age profile, so annual age from 0 through to 100, by gender, male, female, and by location, urban, rural. And most of the modules are disaggregated in this way using arrays. So there's a lot of depth to the model as well. I just wanted to mention there's a brand new version of the model that was released this year by the Millennium Institute, which we'll be also using now in Australia, which is built in Stellar Architect. And they've adjusted the structure to 3 levels now. So we have that top level, which is sort of the helicopter view of the model. It goes down to a meso level, and then to the actual model structure at the bottom. And it's been done to help simplify the model, to make it more modular and make it easier to integrate new updates and things like that when you extend the model, and also highlight some of the key overall dynamics in the model. I guess just briefly, in terms of the model calibration, so as I mentioned, the model includes optimization parameters and calibration variables, and during calibration, we use those optimization features in the software, so multi-parametrical optimization. And a common formulation for these parameters is the use of elasticities. So these are, adjusted during the calibration process. We've done, a lot of structural validation of the model. So has the Millennium Institute over several decades. We run behavioural validation as well, so we produce a range of error statistics and charts, etc., to look at the fit of the model simulations and try to get the best fit possible. And we've also used sensitivity analysis to look at the impact of different exogenous parameters, so really uncertain and potentially impactful exogenous parameters, say on, what would be the impact of higher global temperatures or higher inflation or more geopolitical uncertainty or less trade, less export, demand for exports, etc. So we can sort of test the sensitivity of our results to these different exogenous parameters through Monte Carlo simulations. Okay, so I guess the modelling approach for Transforming Australia was really to model two key pathways for Australia through to 2050 and evaluate these using the SDG targets that we have embedded in the model. So we can compare how these pathways perform on the SDGs. The first pathway was our baseline of business as usual, which really just is a continuation of policy settings. And we compare that against our Transform Australia pathway, which includes a range of SDGs policies, so more ambitious SDGs policies designed to boost progress on the SDGs. And we then evaluate those two pathways on the SDG indicators in both 2030 and in 2050. The Transform Australia pathway is based on this 6 transformations framework, which includes transformations from wellbeing and resilience, sustainable and just economy, sustainable food systems, energy decarbonisation, urban development, and regenerating the environment. And we use these 6 transformations because it helps to provide a nice structure for our pathway. They're also recommended by global experts as having the greatest potential to accelerate progress on the SDGs. And for each of these transformations, we have a set of policy shifts or policy measures that we can implement in the model. So we can quantify each of these policy shifts. So on wellbeing and resilience, it includes investment in health and education, investment in climate change adaptation. We're also able to adjust tax settings, implement, increased social transfers, implement various policies to incentivize, sustainable technology adoption, etc., etc. Overall, the pathway includes an additional 7% of government expenditure over a 10-year period. And that additional expenditure is financed through an increase in tax settings. So we can increase tax on income and profits, on trade, we can increase the GST. We can also target those tax incentives at higher income, higher profits and higher income, so have more progressive tax settings. But overall, the pathway is budget neutral. And yeah, essentially we parameterize the model with quantitative settings for all of these different policy measures, and then we can run our projection for this pathway and evaluate progress on the SDGs in 2030 and 2050. So you can imagine that we have a target value for each of our 80 different SDGs indicators, which enables us to simulate the amount of progress that each pathway makes towards that target. We can then add them together and average them for each of the 17 goals, and we can add them and average them for all of the goals, all 17 goals at the same time, and sort of compare, the outcomes across those two pathways. So this chart just shows the comparison of progress made on the business as usual versus the Transforming Australia pathway for all of the 17 goals. And essentially what it shows is that our Transform Australia pathway performed better than business as usual on 16 of the 17 goals. And when you add all of that together, essentially the Transform Australia pathway reaches around 90% progress on all of the targets that we have in the model, whereas this business as usual pathway sort of peaks and then stagnates, reaching only around 55% progress. So these and a bit more ambitious SDGs policies can really boost progress on the SDGs, and they can be financed, through different settings that we include in the model as well. So it sort of shows, I guess, that, the SDGs are achievable. Perhaps we can't reach 100%, but we can certainly do a lot better. And we can do a lot of cool things with the modelling results as well, decompose, the results for different, to look at how a single policy affects all 17 goals or all 80 indicators, or we can look at how each of the 6 transformations contribute to this additional progress on the SDGs. So if we look at that business as usual at 55%, what is it that boosts our performance on the SDGs through to 90% by 2050? So we can decompose the results by transformation, for example. And when we do that, we can see that some of these transformations actually have a bigger beneficial impact than others, particularly the wellbeing and resilience and the environmental commons, as well as energy decarbonisation. But really the best outcome for the SDGs is when you implement all these things together. So each policy has a unique beneficial contribution to the SDGs. And overall, they're broadly consistent and coherent. So I guess co-benefits between these various transformations outweigh, potential trade-offs. We can also look at the costs associated with these different policies and transformations. So when we look at that, we see that policy measures, for example, relating to the environmental commons and regenerating the environment, the most cost effective, so you get a lot more bang for your buck in terms of those interventions than, say, policies around a sustainable and just economy, which include things like social transfers, etc. And when we look at the results from the sensitivity analysis, so this is when we run thousands of Monte Carlo simulations and randomly adjust these, different exogenous assumptions around global temperatures or geopolitical uncertainty, trade, climate change impacts, etc. And we see that, if we have a much more hostile global outlook, we would actually lose some of the gains projected, but certainly not all of them. So they are pretty resilient to changes in future conditions and to this, deep uncertainty in the future. We can also unpack that a bit by different goals, for example, and see which goals are most sensitive to changes in global settings. So, for example, the goal of 1 on poverty and goal 8 and goal 16 are particularly susceptible to changes in global outlook. So I'll just go through an example. I mean, there's so many different findings we could look at, but just as an example, I'll just run quickly through the wellbeing and resilience transformation and some of the policies and key results for some indicators, as well as some of the key dynamics, I guess, that are driving these results, which might be of interest. So for the wellbeing and resilience transformation, we include policies around increasing government investment in health and education, in climate change adaptation. We also assume a more rapid transition to net zero, which reduces a bit those climate change impacts. And this has implications for a range of different goals, but in particular, goal 3 on health, goal 4 on education, and goal 13 on climate action. So, for example, when we look at the projections for life expectancy, we can see that that Transform Australia pathway in green delivers a boost in life expectancy by 2050 compared to the baseline, which is that dotted grey line. Similarly, if we look at persons affected by disasters, we see a better outcome for that Transform Australia pathway, or for tertiary education, again, a boost in education. And, there's a lot of complex dynamics that are going on in the model that result in these different outcomes. And indeed, these variables are interconnected in a number of ways. Say, for example, tertiary education is actually a driver of mortality rates. So increases in education reduce mortality rates and boost life expectancy. Similarly, persons affected by disasters can increase mortality rates and reduce life expectancy. So we can start to get a broader picture of that. There's also a range of other drivers of mortality rates in the model. So when you increase undernutrition or road fatalities or violence or PM2.5 emissions, you also increase mortality rates. While a range of drivers can also reduce mortality rates, including per capita income, access to services, health expenditure, etc. So we can also then see how these different policies begin to plug into the model. So we have this increased education expenditure, increased health expenditure, and expenditure on adaptation, which then influence these drivers of mortality rates and flow through to life expectancy. That, of course, has a lot of feedbacks as well, because life expectancy is a driver of productivity, and productivity is a driver of per capita income. So we can see this health feedback where life expectancy increases per capita income, which reduces mortality rates and boosts life expectancy. So that's a positive feedback. Similarly for education, we can see the productivity increases income as well as years of schooling, which feedbacks to life expectancy. And then finally, through government revenue, we can see that productivity increasing per capita income can also increase government revenue, which then can be used for these various policies. So there's these reinforcing feedbacks that play out in the model. We can also then get a broader picture. I mean, we've got all these other policies for different transformations, say, for example, in orange red there, the sustainable just economy, investments in infrastructure, female participation in the workforce, social transfers, as well as additional tax, all have important impacts on productivity and on income, and these result in feedbacks through the model. I won't go into that in more detail, but just to show that this is a very complex model and there's so many complex feedbacks, and I guess a real strength of the model is that, this integration and that it's able to show, the cumulative effect of these different interventions on the SDGs over time, and then you can sort of explore the model and understand these different feedbacks. Another really important feedback in the model I just wanted to touch on quickly is around productivity. So productivity is a key driver, if you like, of GDP. And that has a range of different drivers in the model, including life expectancy, years of schooling, infrastructure, gender equity, governance, as well as a number of drivers that reduce productivity, including around climate change impacts, resource efficiency targets, energy prices. And the combination of these different drivers, these sort of positive and negative drivers, then result in the overall projections on GDP, and economic growth is one of the key drivers that then feedback through the model. So that's sort of, I guess, a very linear way of looking at it. We've also been doing a new paper where we're trying to draw out some of these key high-level feedbacks in the model. And we found that a lot of them actually feedback through productivity. In particular, these sort of reinforcing socio-economic dynamics that are in the model. So, for example, when you increase productivity in GDP, that flows through to an increase in income, which can improve health and education outcomes, and then feedbacks again to boost productivity. Similarly, that increase in GDP can also increase the government budget, increase investment in infrastructure, investment in health and education, which then feeds again to productivity. So we can really sort of see the centrality of productivity in this, and that really feeds into the national discussions at the moment, where Labor's second term is focused very much on productivity. Another insight that we got from this, though, is that you would expect from these dynamics that the poverty rate would be going down overall over time. But what we see in the data is that poverty rate has pretty much not changed, that it's remained around 13% for several decades now. And that really shows that, for some of these indicators, that in order to address poverty, we really need additional policy interventions to bring that rate down. When we implement, additional social transfers, we find that we can halve poverty by 2050 through these types of measures. Another thing we've found is that there's also a second half of this picture which relates to environmental dynamics, and many of these create balancing feedbacks, and this is the classic sort of socio-economic and environmental trade-offs that people talk about. So as you increase GDP, you also increase energy and resource consumption and greenhouse gas emissions. And over time, that has a feedback where the impacts from climate change actually reduce productivity. And this is something that plays out with quite a long delay and will get worse and worse over time. And what we see in that is also that there's a really centrality of the energy decarbonisation in this whole, in this broader picture, that increasing that share of renewables reduces energy consumption, it reduces emissions, so it weakens these balancing feedbacks. And it also increases investment in green industry, green manufacturing, green hydrogen, green steel, etc., which can boost GDP. So it's really pretty critical, and we see that play out in the modelling results. So we can look at what is the impact of these different transformations on all 17 SDGs and sort of unpack these results a bit more. So this chart essentially shows the amount of progress or additional progress you get on each of the 17 goals as a result of each of these 6 transformations. So the coloured segments there show the amount of additional progress you get from the 6 different transformations. And what we see from this is that the well-being transformation really has big positive benefits for poverty, for nutrition, for cities and climate resilience. We see that energy decarbonisation has really big benefits for clean energy, for the economy, for clean industry, etc. Whereas the transformation on regenerating the environmental commons doesn't have a lot of co-benefits, but it has really big benefits for the biodiversity goals on life on land and life on water. So we can start to unpack, how these feedbacks actually, drive different results in the model. Okay, so that's enough looking at the numbers. Just quickly, we launched this project in February this year, and we've been doing a lot of presentations. We had a big launch at the Press Club, an online launch. We've been doing a bit of a roadshow with presentations to different government departments. So I presented to the Productivity Commissioner and 20 Assistant Commissioners. I presented to 200 staff at Treasury. We presented to super funds and business and NGOs and different research institutes, etc. in Australia. And each time we've been learning a bit more about which key messages and key results should we focus on, and what resonates the most with different audiences. And I guess just some highlights. We've been able to demonstrate the utility of the SDGs, not only in assessing progress, but also in prioritising investment and designing policy. We've been able to show that, one of the challenges in the past is we've said, should we set all these SDGs targets and, we should all be working towards these targets? And governments often said, well, they look impossible, or, we'll never achieve those targets. So we've sort of been able to show that, many of these targets are actually achievable with, increased policy ambition, and that there's a crucial role for government in this, that government shouldn't sit back and just let the markets, do all the work. The modelling has really supported some of the key government's priorities around decarbonisation, made in Australia, etc. Provided new evidence on other policies which we think are crucial around poverty and income inequality. And, you know, we're really trying to play into the narrative and discourse around the role of government, you know, the importance of tax and revenue, more diverse drivers of productivity than just, you know, removing regulation, and addressing poverty and inequality as being central to all of this. But we've also had a number of challenges. You know, stakeholders are not very familiar with system dynamics modelling, and they're even sceptical, I think, in many cases of systems thinking approaches. I've heard systems people referred to as weird by governments before. And that's problematic because, you know, there's a really, in any modelling, there's an important role of trust and legitimacy and being seen as having expertise. And there's a lot more familiarity and use of economic models, sort of more traditional econometric models by government. I think, you know, the results of this particular assessment are also challenging because they're very broad and it's very complex, and governments are often, you know, really interested in a very specific policy. So, you know, on housing affordability, on mental health, on employment services, etc. And there's less interest in this bigger picture, sort of long-term outcomes around, you know, sustainable development, intergenerational equity, policy synergies and trade-offs, etc. But it's really, you know, the latest project has really helped us to formulate some ideas about what to do next with the Transforming Australia project in our next assessment. Anyway, okay, I'll wrap it up there. Sorry, I spoke a bit too long. Apologies for that.
Thanks so much, Cameron. Can we just get a round of applause here? Yeah, super interesting. Thank you. We have like 5 minutes. I'm going to be very fast. Does anyone have a question? Shane.
Yeah, thank you, Cameron. Terrific. Across both of your projects that you presented, which I thought were both really well done, there were these policies in the end which required investment or expenditure in a whole variety of ways, and then those investments had some impact on, you know, some impact on the rest of the model, reducing emissions or increasing health outcomes or something else. And it strikes me that the calibration can be really helpful. The historical data can be really helpful to estimate parameter values for the elasticity relationships that you're talking about. But for some of the interventions, these policies where you're spending money and getting some effectiveness out of every dollar or $1,000 or $1 million spent, I would imagine there's a lot more uncertainty about that because there's probably less historical data. So I'd love for you just to explain briefly sort of, you know, how you validated or built confidence in those assumptions.
Yeah. Thanks, Shane. It's a good question. I guess in different ways in the different models. In terms of the air pollution study, so we used unit costs, which were based on, you know, academic literature, some air pollution models that have been developed in Europe, and data that was provided to us from the countries that we worked in. But there is a lot of uncertainty in terms of those unit costs, definitely. And I guess that's why, you know, in the user interface, we have the ability to be able to play around with those unit costs. So we allow users to set their own assumptions for those types of variables because, yeah, I agree, there is a lot of uncertainty. We can then run sensitivity analysis with those parameters and see what the effects are if we really overestimate or underestimate, you know, policy costs. So yeah, I guess in brief, that's probably, you know, the main way we would try to work with that. It works a little bit different in the ISDG model because, you know, some of the policies, you know, vary quite a lot in the way they're formulated. And some of them relate to government investment, which is based on government expenditure data. So we do have quite a long time series on government expenditure data, which we can calibrate to, which, you know, delivers a certain amount of outcome in terms of different indicators. Yeah.
Terrific. Thanks, Cameron.
Sounds good. Do we have another question in the room? We have a question online. Stephen, quick, and then Claire, and then.
Thanks, Cameron. That was really wonderful. A quick question just about the Thai and Laos studies. Could you just give us a quick profile of the types of stakeholders you were working with in the participative modelling component, please?
Yeah, sure. Thanks, Stephen. So it was a different, it's stakeholders from a range of different backgrounds, but in each country, the stakeholder list was put together with the UN country officers, who have a lot of connections in the country. So it included the national government, the provincial government, so the local government in those provinces. It included civil society groups. So there's a range of different civil society groups working on air pollution, various aspects of air pollution and waste and things like that. It included some researchers from universities, and then also business, so some business interests from the different provinces, and international organisations, so a range of different representatives from UN agencies, etc. So it was a bit of a mix.
Claire, do you want to take?
Yep, just unmuting. Hey, Cameron, that was fabulous. It's really good to see what you've been doing in this space. And to be honest, the complexity is mind-boggling. I'm not surprised you get mistrust and cynicism from some of the people you're presenting to, because it's just so new to most of them. I was just going to ask a practical question on whether you've got any hints for building trust in a really complex model, which the people in the room who are being introduced to really won't be able to understand what's under the covers.
Yeah, well, g'day, Claire. Good to see you again.
And you?
And I guess, you know, there's different ways you could try to do this. I think, you know, the more you engage with people, the more you build trust. I think, you know, having as much as this may sound unfortunate, having publications in high-profile journals helps to build that legitimacy, which is why we have sort of targeted, you know, Nature publications, because the peer review process is very extensive. I've had presented, you know, I've been asked to sort of do side presentations to different modelling experts and things like that. So modelers will then interrogate you about different aspects of the model. You know, in a different government project, which I was going to talk about today, which I didn't get a chance to, we actually gave the model to Ernst & Young, who then validated the model. So they went through every variable, everything in the model, and ripped it apart. And you know, that validation report then goes to government, and government has some confidence. So yeah, there's different ways you can do this, but I think engaging and building that relationship over time is probably the center of it. Yeah.
Great. Thanks, Cameron. See you soon. Bye.
Hossein, do you reckon we have time enough for the online question?
Just one question I'm reading through so quickly. Just
very
on
quiet.
Yeah.
Sorry.
You can read it from my voice.
Yeah. Okay, we'll just try it quickly. So Cameron, I don't know if you see the question in the chat, but can the model be used to test scenarios for meeting net zero targets and assess the potential impacts on GDP, inflation, and employment? Rassam has seen a model a presentation by CSIRO where a CSG model showed negative economic impacts on a net zero scenario. So I guess that's the motivation for the question.
Yeah, I mean, absolutely. And one of the main problems with economic models and economic modelling of net zero that I've seen is it doesn't include climate change impacts. Our model does, and that's crucial because they're just assuming that, you know, if you just keep pumping out emissions, you're not going to have any negative long-term impacts on the economy, which is not correct. So it inflates the benefits, or it inflates the costs of net zero, the net zero transition, I think. So having that broader picture is important. What we've seen also, I guess, is in terms of, you know, I guess one of the key feedbacks that these models have is around energy prices and energy costs, which can be a drag on productivity. And that may be a short-term or medium-term issue, but over the long term, it's certainly going to be a positive, a benefit to productivity through cheaper energy. So, yeah, I think it's important that you factor in time scale into these things, and also, you know, the impacts of climate change.
Cool. Sounds really good. I think we'll better stop here. I've got like 5 questions, but I'm going to just write them to you in an email. We'll call you separately. All right, cool.
Yeah.
Well, thank you again, just from all of us. And just a quick plug for those that are online or listening to the video, that the System Dynamics International Conference is coming up in Boston, beginning of August. I think it's 3rd to 7th or 2nd to 7th of August. There's an online version available. And also we're starting to make lots of plans around the symposium in February here in Melbourne. It's going to be hosted by Deakin University, but it's going to be in Melbourne CBD. So we hope we can attract lots of people. Okay, but you're going to hear more in the next newsletter. Okay.
Thanks so much, Cameron.
Yeah, thank you so much, Cameron, from all
Thanks,
of us.
everyone.
Okay, bye.
Yeah.